So what I'm going to establish in this video is the existence of certain terms and certain ideas in graphs of exponential functions, and I'm going to present it to you in a visual manner. See, here we have the graph of y, or f of x. Let me write this down. The one I've already graphed was f of x is going to be equal to 3 to the x power. But what I want to do here is I want to subtract 1 to every x plot that we do here. Now what's that going to look like? And so in this video I'm going to describe what we can use within the idea of transformations to shift an exponential function graph. So let's get to it, shall we? Okay, so now we know that we have -1 right next to this x, and so what that's going to mean is that we're going to have to think in opposites. We're going to move 1 unit to the right. So essentially every coordinate or every point here is going to be moved 1 to the right. 1 to the right. Right? So what color should we use? Okay, we used red. And so our new graph of f of x is going to be equal to 3 to the power of x minus 1. 3 to the power of x minus 1. And so if you want t-table to show you how this actually does work, and it's actually a really good method to do things, and then I'll be glad to show you guys. Not some good lines there, but they should work, right? And they should work. Let's use some blue colors. Okay, and I'm going to use our standard -2, -1, 0, 1, and 2. And let's see here. 0. Let's use 0 first as our starting point, right? I like to use that number. And if you notice here, our 0 was 1. And 0, 1 is a really common point if you don't have anything changing it. If you don't have this a to the power of x form, where there's no other variables, then things are going to change, right? Are you guys excited to see the change? Alright. Probably not. 3, 0 minus 1, 3 to the -1 power, and from basic exponential rules we know that this is going to be 3, or 1 over 3 actually, I'm sorry, not speaking well, it's early in the morning, so 1/3, right? And if we check our answer, all we have to do is set 1 on top of the negative exponent to make it positive, right? So 0, 1/3, -1 is going to be equal to 3 to the -2, and that's going to be equal to this 1 over 3 to the power of 2, and that's going to be equal to 1/9. 1/9, right? Awesome. And just to make sure, oh, actually, I was here, I'm sorry. I am so sorry about that. Okay, now we're going to want 3 to the -3rd power. That's going to be equal to 1 over 3 to the 3rd power from our basic exponential rules, and that's going to be equal to 1 over 3 times 3 times 3. What is that? 3 times 3 is 9, and then 9 times 3 is 27. Correct? I stand corrected. 1 over 27. It's looking good so far. Looking good so far. Right? And now I'm going to assume that this is going to be equal to 1, 1, 1, because I see a pattern that everything's being multiplied by 3, right? So let's do that. Let's check to make sure, right? 1, we plug 1 for the x. 1 minus 1, that's going to be equal to 3 0th power, which is always going to be equal to 1. So I stand corrected. 2 minus 1, that's going to be equal to 3 to the 1st power, and we know that is 3. So let's plot these points. Okay, so I've gone ahead and done the graph and cleared up a few things, right? And let's observe the new graph. It looks exactly as I said it would be. It's just shift the 1 unit to the right, because, remember, because we're subtracting 1 to the x, and because of that, we're going to be 1 unit delayed. Think of it that way. We're going to be 1 unit delayed, and so we're going to shift 1 unit to the right each time. So, for example, remember here, at -2, we had 1/9, remember? But in this new graph, we had -1 as that point, right? -1 1/9 in our new graph. And so what I want to establish is this idea of horizontal asymptote, domain, and range, because I was really vague in the first lesson, and I apologize with that. And so now I've decided to make a little bit more longer videos so you guys can harness the content. You guys can establish, or you guys can clearly learn this idea. So our horizontal asymptote, what does that mean? Well, if you're new to this concept of approaching, which we'll see later on in our Algebra 2 studies when we're introduced into geometric sequences, etc., etc., and maybe even limits, we might do limits. We know that our horizontal asymptote is going to be a line that approaches, or the number that our line keeps approaching but will never actually touch. And if you're wondering why it won't actually touch this y-axis, how I try to illustrate it here, but when you're doing it on a computer, it's not really hard, not really easy to do, not really feasible. So our horizontal asymptote here is going to remain constant. It's going to be y = 0. Y = 0. And if you're a little confused, just remember that we're never going to touch y = 0. It's going to keep getting closer and closer, and because of our exponential rules, we can never actually touch 0. And so our asymptote, because it's going to keep approaching, y is going to be equal to y = 0. Y = 0. Why don't I use red, right? Red, because we did red for our graph. Yeah, y = 0. I wasted your time, sorry. Okay, domain. Domain. We're going to use an x here, right? Because you should remember from our Algebra 1 studies that our domain would be the range of all x's. The range, I'm sorry for using the word range, I couldn't find a good synonym for it, but all the x values that our line contains. And we know that this line will contain all of the x values. It's going to keep stretching the x values indefinitely. It's going to keep going on forever. And so we know that for all exponential functions, for all exponentials, that our domain is going to be all real numbers for all exponentials. So you might write it in a number of different ways. You might see an r like this, or sorry about that, or you could see something like this, -infinity. This is probably going to be wanted by your teacher, -infinity to +infinity. What about range? Well, range is really interesting in this graph, and range is really interesting in many exponential functions. Let me rephrase that, in all exponential functions. Your range is going to be the range of all y values. We know that's going to be limited. We know that's it's not going to go to the negatives. It's not going to touch any of these numbers, right? So if I were to show you, remember this line, okay, let me extend it. These would be your negatives. It's not going to touch it. Because you have a horizontal asymptote is y = 0, that is going to be your starting point, right? It's going to have to go. The numbers you want have to be from 0 to infinity, right? You cannot have a negative, or you could just have y is going to be greater than 0. And I hope this video was really helpful, and I hope it expanded your mind. We're going to be looking at some real-world applications and some ways that we can incorporate it into our further studies in the next few videos. See ya.